welcome to Two Projects. In this video, we are going to explain the project Detecting Network Transmission Anomalies using Autoencoders SVM Neural Network on Multi-Class NSL KDD dataset. Introduction. The project delves into the intricate domain of cybersecurity, specifically addressing threats posed by nation states and vulnerabilities originating from everyday devices like Internet of Things gadgets. This underscores the imperative need for robust cybersecurity measures. The shift to remote work prompted by the COVID-19 crisis has led to a noticeable upswing in data breaches and sophisticated man in the middle attacks. This surge underscores the demand for innovative security solutions to safeguard remote work environments. Organizations migrating their IT infrastructure to the cloud face a concurrent escalation in severe data breaches. Notable incidents such as the Equifax breach emphasize the critical necessity for fortified security measures in the evolving landscape of cloud based operations. So, a pivotal aspect of this project involves introducing deep autoencoder, that is DAE technology, for multi-class feature fusion in anomaly detection. This departure from conventional methods like principal component analysis, that is PCA, holds the promise of a more effective approach to cybersecurity. And the adoption of deep autoencoder technology signifies a forward looking strategy, leveraging its capacity to understand complex patterns and representations in data. This positions DAE as a potentially superior method for anomaly detection in the dynamic and complex realm of cybersecurity. Objective of the project. So, as I mentioned earlier, the primary goal is to create advanced and effective solutions to strengthen cybersecurity defenses. This involves addressing threats originating from nation states and vulnerabilities emerging from the increasing trends in remote work and cloud migration. And the project aims to thoroughly explore and analyze the NSL KDD dataset. By doing so, it seeks to uncover valuable insights into network behaviors. These insights serve as the basis for developing robust intrusion detection models capable of identifying and responding to potential security threats. And the objective is to integrate a variety of models, including support vector machines, principal component analysis with SVM, and deep autoencoder with SVM and L1 and L2. This integration is geared towards achieving a comprehensive understanding of intrusion detection mechanisms. By combining different approaches, the project aims to enhance the accuracy and effectiveness of the overall cybersecurity system. Requirements needed to execute this project are: software requirements. Software needed is Anaconda. Primary language used is Python. Front-end framework used is Flask. Backend framework used is Jupyter Notebook. Database used is SQLite 3. And front-end technologies used are HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements needed are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Now we'll discuss the working modules of law of work. So the first step is important required packages. So in this step, essential Python libraries such as NumPy, Pandas, sklearn, TensorFlow with Keras, Matplotlib, and Seaborn are imported. These packages form the foundational toolkit for data handling, processing, visualization, and machine learning model development. The second step is exploring the dataset. So the project focuses on the NSL KDD dataset, involving an in-depth exploration to understand its structure, features, and patterns. This initial exploration sets the groundwork for subsequent data processing and model building steps. The third step is data processing. So, data processing encompasses several key actions using Pandas and Keras data frames. This involves converting the dataset into appropriate formats such as Pandas data frame and Keras data frame. Additionally, any unnecessary columns are dropped, streamlining the dataset for further analysis. The next step is visualization using Seaborn and Matplotlib. So here, utilizing Seaborn and Matplotlib, the project visually represents the dataset. This step aids in gaining insights into data distributions, patterns, and potential correlations, providing a clearer understanding of the dataset's characteristics. The next step is label encoding using label encoder. In this step, to prepare the data for machine learning models, categorical features are encoded using the label encoder. This transformation converts categorical data into numerical format, ensuring compatibility with various machine learning models. The next step is feature selection. So, feature selection is crucial for model efficiency. The project employs select percentile with mutual information classification to retain the most informative features, enhancing the model's predictive power while reducing computational complexity. The next step is train and test split. Here, the dataset is divided into training and testing sets to assess the model's performance accurately. This step involves separating the data into input features X and target label that is Y for both deep learning and machine learning models. The next step is training and building the model. So, different models are trained and built in this stage, including support vector machine PCA with SVM, deep autoencoder SVM with L1, and deep autoencoder SVM with L2. Each model is designed to address specific aspects of intrusion detection, leveraging diverse techniques for enhanced accuracy. And in the next step, as an extension, the project introduces hybrid models such as voting classifiers and stacking classifiers. These models combine predictions from multiple individual models, enhancing overall accuracy and robustness in intrusion detection. And the project integrates Flask, a web framework with SQLite for user authentication. This provides a secure environment for user sign up and sign in, ensuring controlled access to the system. So, after signing in, users input feature values, and the system pre processes this input for prediction. This involves transforming user input into a format suitable for the trained models. And the trained models are utilized to predict outcomes based on the pre processed user input. And the final prediction outcome is then displayed through the front end, providing users with insights into potential security threats. This user friendly interface enhances the accessibility and practicality of the system. Now we'll understand about the algorithms used. So the first algorithm built is support vector machine, that is SVM. So support vector machines are employed as a fundamental algorithm for intrusion detection. SVM works by finding a hyperplane that best separates different classes in the feature space. It aims to maximize the margin between classes while minimizing classification errors. SVM is chosen for its effectiveness in handling complex decision boundaries, making it suitable for identifying intricate patterns in cybersecurity datasets like NSL KDD. The next algorithm built is principal component analysis, that is PCA with SVM. So PCA is applied as a dimensionality reduction technique, particularly in combination with SVM. PCA transforms the dataset into a lower dimensional space by capturing the most significant features. This helps SVM operate more efficiently, especially when dealing with a high number of features. The combination of PCA and SVM enhances the model's ability to discern relevant patterns in the dataset. The next one is deep autoencoder with SVM with L1 regularization. So deep autoencoder with SVM with L1 regularization is a neural network based approach for anomaly detection. DA is learned to encode input data into a compressed representation and then reconstruct it. By incorporating SVM with L1 regularization, the model encourages sparsity in the learned features, making it adept at identifying anomalies. This hybrid approach is selected for its capability to capture intricate nonlinear relationships in the data. And the next algorithm built is deep autoencoder with SVM with L2 regularization. Similar to the L1 regularization variant, deep autoencoder with SVM with L2 regularization combines the strengths of deep autoencoders with the regularization effect of L2. This regularization method helps prevent overfitting and improves the generalization of the model. L2 regularization is particularly beneficial in scenarios where the dataset contains noise or irrelevant features. The DAE with SVM L2 approach is chosen for its robustness in handling such complexities in cybersecurity datasets. Now we see the comparison graphs. So this is the horizontal bar graph comparing accuracies of different algorithms. In this graph on x-axis I have accuracy scores and on y-axis I have algorithm names. So accuracy measures the overall correctness of predictions, showing the percentage of correctly classified instances. This is precision scores comparison graph. In this graph on x-axis I have precision scores and on y-axis I have algorithm names. So precision measures the accuracy of positive predictions, indicating how many predicted positives were actually correct. This is recall scores comparison graph. In this graph on x-axis I have recall scores and on y-axis I have algorithm names. So recall measures the ability to identify all relevant instances, showing how many actual positives were correctly predicted. And this is F1 scores comparison graph. In this graph on x-axis I have F1 scores and on y-axis I have algorithm names. So F1 score combines precision and recall into a single metric, balancing accuracy and completeness in predictions. So the algorithm which is best performing in all the performance metrics will be used for predictions. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code file. So this is NSL KDD folder in which I have NSL KDD intrusion dataset with 5 different class labels on which we will train the models. This is static folder. This folder consists of files related to CSS, JavaScript and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML pages. This is model file which contains algorithm information. This file will be loaded into the project code during runtime to utilize the trained models. This is notebook Jupyter source file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. And this is signup.db file. This file is the database file used to store user information. So now copy the path of the code folder from the address bar of the file explorer. I'm copying it. Open Anaconda prompt. So use the command cd followed by a space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. So now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So here we can see a sign up link, click on it. So if we are new users, we have to register first. Fill in all these details and click on register button to sign up. And if we already have an account, we can directly log in by clicking on this link. So as I already have an account, I'm clicking on this link. So here we have to provide our credentials, username and password and click on login button. So it has redirected us to the detection page. So now we have to fill in these parameters and click on predict button to get the detections. So first we'll understand these parameters. So the first one is service. It identifies the network service type revealing the protocol, example HTTP, involved in the connection. Flag represents connection status indicating initiation, closure or encountered errors. SRC bytes denotes bytes sent from the source, providing insights into transmitted data volume. DST bytes represents bytes received by the destination, indicating the volume of received data. Count signifies the number of connections for the same host and service combination, measuring frequency. Error rate indicates the percentage of source side connections encountering errors. SRV's error rate represents the percentage of service side connections encountering errors. Same SRV rate denotes the percentage of connections to the same service, indicating concentration around specific services. Different SRV rate represents the percentage of connections to different services, providing diversity insights. DST host SRV count indicates the number of connections to the same service on the destination host. DST host same SRV rate represents the percentage of connections to the same service on the destination host. DST host different SRV rate denotes the percentage of connections to different services on the destination host. DST host error rate represents the percentage of destination host connections encountering errors, and the DST host service error rate represents the percentage of service side errors on the destination host. So now we'll fill in these parameters. So service would be 14, flag would be 9, SRC bytes would be 1032, DST bytes is 0, count would be 142, server rate would be 0, SRV error rate would be 0, same SRV rate would be 1, different SRV rate would be 0, DST host SRV count would be 142, DST host same SRV rate would be 0.56, DST host different SRV rate would be 0.01, DST host error rate would be 0, and DST host service error rate would be 0. Now click on predict button. So here we can see the outcome, that is there is an attack detected and attack type is DDoS. So we'll try again. Click on home link. We'll try giving another set of parameters. So this time service would be 22. Flag would be 9. SRC bytes would be 200. DST bytes would be 2498. Count is 13. Error rate is 0. SRV error rate is 0. Same SRV rate would be 1. Different SRV rate would be 0. DST host SRV count would be 255. DST host same SRV rate would be 1. DST host different SRV rate would be 0. DST host error rate would be 0. And DST host SRV error rate would be 0. Now click on predict button. So here we can see the result, that is there is a no attack detected, it is normal. So similarly, we can give any set of parameters and can get the detections. So we can get the detections as normal, DDoS, probe, U2R and R2L. So we'll try again, click on home link. I have entered the values. Now click on predict button. So this time the attack type is U2R. Now click on sign out. So the conclusion here is the project concludes with the successful development and implementation of innovative cybersecurity solutions integrating diverse algorithms such as SVM, PCA with SVM, and deep autoencoder with SVM and with L1 and L2. These advanced techniques significantly enhance the accuracy and efficiency of intrusion detection in complex network environments. The project effectively tackles the evolving challenges in cybersecurity, especially those arising from nation state threats, vulnerabilities associated with remote work, and data breaches during cloud migration. By employing sophisticated models, the system is well equipped to detect and mitigate potential security risks. And the integration of hybrid models, including voting classifiers and stacking classifiers, exemplifies the commitment to achieving a more robust and accurate intrusion detection system. These models combine the strengths of various algorithms, contributing to a comprehensive and reliable defense against cyber threats. And the beneficiaries of this project extend to organizations and individuals relying on secure network environments. The system's real time prediction capabilities and user friendly interface, implemented through the Flask framework, empower users to proactively address cybersecurity concerns. The practical implications are far reaching, enhancing the overall security posture of systems in the face of contemporary threats. And the project significantly contributes to the field of cybersecurity by introducing novel approaches to intrusion detection. The utilization of deep autoencoders, PCA, and hybrid models showcases a forward thinking strategy to address the dynamic landscape of cyber threats. This work lays the foundation for continued advancements in cybersecurity research and practices.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.